Happy Thursday to you guys. And I know that most all of what you have on your mind right now is the fact that tomorrow is the start of spring break. So I don't have a ton of stuff to present to you today. Most of what we're going to do is I think all of what we're going to do today is just review. But we're starting a new chapter, and I want to just give you a little bit of motivation for where we're headed here. You've got, just as a reminder, after spring break, you've got an assignment due that is on section 5.10, which is what we talked about yesterday, as well as the material from today. And again, the material from today should be review, but you'll have some time in class to work on that. So hopefully you can get a fair amount of your homework done even today, so you don't have a ton over the spring break. I don't really want to lob a bunch of homework on you over spring break. Now, chapter 7, I mentioned that I took chapter 6 and chapter 7 and I actually switched them. Chapter 7 is on integration techniques. The idea is that taking derivatives of some complicated function is not always fun, but you can always do it, assuming you know the derivatives of the individual functions within. Okay, if I ask you for the derivative of e to the tangent of the square root of x over x minus 1 or something like that, it's ugly. You have to do the quotient rule, you have to do the chain rule maybe several times, but you can do it. Just take a couple minutes, you can do it. If I ask you to integrate that same function, that is a super hard question. It may not even actually be possible to find an elementary antiderivative of this. We know that it has one from the fundamental theorem of calculus, but being able to find a nice formula for something like this is very, 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 very difficult. Okay, integration is generally much, much, much harder than differentiation. We can do it in special cases, but in general it's very hard. So what we try to do, we know how to do integration in very special cases. So in harder cases, the general setup is we try to take those harder cases and turn them into the easier cases so that we could then do an integral. Okay, again, when we are faced with a hard integral, we have techniques and we're going to develop more techniques. That's actually what this entire chapter is about. How do I take a hard integral and do something to it so I get an easier integral? And the idea is if I can take this hard integral, do something, make it easier, maybe do something else, make it even easier, do something else, make it easier, and I have a rule for this, then we're good. Okay? So what we're going to do here in section 7.1, this is just going to be a review of the integration techniques that we have up to this point. How do we integrate? What are our approaches? If I just hand you an integral, what are the approaches that we take? Kind of like, you remember we had a list of things. When I give you a limit, what do? Well, if it's of this form, you try this. If you do, we're gonna eventually, by the end of this chapter, have a list of things that if you have an integral of this form, try this. If you have an integral of this form where you notice this, try this. Okay. Now the reason I switched chapter 7 and chapter 6 is that there's some integrals in chapter 6 that we actually need the techniques from in chapter 7. If we have those techniques, then there are some things, really cool things that we'll be able to do in chapter 6 that otherwise we can't do. Okay, so I'm switching chapter 7 and chapter 6. And you'll see why when we get to that a little bit later. Okay. So let's just review what our integration techniques are. Now, there's going to be a step 0 here, which is not cry. There's no crying in integration. Well, maybe there is crying in integration, but hopefully we won't be crying in integration, okay? The first step, or the 0th step here, is if I hand you an integral where you have an immediate rule to take the integral, use the rule. So apply your integration rules if possible. Here's what I mean by that. Let me give you an example. And I can't kind of do, I guess I can do an example off to the side here. I'll do a few examples over here, just so you can kind of see what I'm talking about. So if I gave you, what's the integral of 1 over x dx? That was just if that was my question, integral of 1 over x dx. You don't have to do a lot right here, right? You just say it's natural log of absolute value of x plus c. You've got a rule for that. Or if I said, what's the integral of x cubed dx? You've got a rule for that. That's 1/4 x to the 4th plus c. Okay, or what's the integral of sine? You've got a rule for that. That's negative cosine. Or if I said, what's the integral of sinh? Now we just did sinh, so you should know the integral of sinh is cosh. Okay, you actually have a whole list of these rules. I gave you a handout. That handout has all of your rules except sinh and cosh. You may want to add sinh and cosh to that handout. But that is your kind of basic, if I give you one of those, you're good to go. If I give you e to the x, or 2 to the x, or one of those, you're good. Okay? If it's not immediately one of those rules, this is where we have to start getting things, doing something. And the first technique, which it's easy for me to say but not necessarily to do, is what I'm going to call simplify. Simplify the integral so that it's in a form where you can apply rules. Now we've seen 4 or 5 things that probably fit under this category. So let me give you a few examples here. One way that we sometimes simplify is we multiply out. We multiply an integral out. Okay, so what I mean by that is something like this. If I gave you the integral of x minus 3 times x squared dx, okay, you don't have a rule to do a product like this, but if you multiplied this out as x cubed minus 3x squared, now you have rules for both of those, right? You can do that. That's not a problem. Okay, I can do that. That's 1/4 x to the 4th minus x cubed plus my constant, right? So multiplying out is one of our simplifying techniques that we use. Another one, so there we're looking for, when we do that when we see products, right? Maybe I can put in red here. Here's what we're looking for. We're looking for a product there, right? So if I see a product, maybe I might try to multiply it out. Same thing for division. I might divide out if I see a quotient. Okay, and you've seen these are these are things that you've seen before. So if I have, for instance, x squared minus 3 over x, the best way to do that integral is just to take x squared over x minus 3 over x. Okay, now x squared over x is just x, and I've got the 3 over x, and then this is now an integral that I can do. We've gotten to a place where it's easier. This is 1/2 x squared. That's negative 3 natural log absolute value of x. We're good to go. We're golden there. But the key is dividing out. That makes the integral simpler. Okay. Another thing that is sometimes helpful here is factor and cancel. So for instance, if I saw something like x plus 5 over x squared plus 6x plus 5, one of the things that I notice is that the bottom factors, and it turns out it factors as x plus 5 times something, in this case x plus 5 times x plus 1. And these things, I have an x plus 5 on the top and bottom, so they end up canceling, and I end up with a much simpler integral there. Right? And this turns out to be the natural log of x plus 1 plus c. So again, I'm trying to simplify. I'm trying to get something better. So I might factor and cancel if the top or the bottom is like a polynomial over a polynomial where there's some term that can factor. Okay, so I might simplify that way. Another thing maybe a little bit related to that is if I have a polynomial over a polynomial, then I might do polynomial long division. Okay, I might do polynomial long division if what I'm looking at is a polynomial over another polynomial. Okay, and particularly a polynomial where the degree of the top is bigger than or equal to the degree of the bottom. So you've seen these before. I'm not going to go into the gory detail, but if I saw x cubed over x squared plus 1, the first thing I would do here, since it's a polynomial over polynomial, and the degree of the top is bigger than the degree of the bottom, I would start by doing some long division. And I would need all of these terms. X cubed plus 0x squared plus 0x plus 0. And over here I would have x squared plus 0x plus 1. And then I would say to get x squared into x cubed, I need to multiply by x. So I would have x cubed plus 0x squared plus 1x. When I subtract, I get a negative x, and that's going to be my remainder. So then I'm going to get x minus x over x squared plus 1. Okay, and now at least this part is something simple that I can do. This I'll have to do something else with, but it's also simpler than what was there before. So again, these techniques are just supposed to get my integrals to become simpler than they were before. Another one that maybe I can put alongside this is that sometimes separating the integrands, separating the integrals, can actually be helpful here. So let me show you an example of what I mean here. There's actually I think you've probably seen at least one of these on your homework. But if, for example, I had the integral of x plus 1 over the square root of 1 minus x squared, one of the things that we saw is that if I break this into x over, it's kind of like I'm dividing out a little bit, but I'm breaking this apart into x over the square root of 1 minus x squared, plus the integral of 1 over the square root of 1 minus x squared. And the reason that I do this, it seems to make it more complicated, but in fact, this integral and this integral I would do very differently. This one I actually have a rule for. This is arcsine. This one I would end up doing substitution on. Okay? So sometimes we want to break integrals apart because we're going to deal with the integrands. We're going to deal with the things inside the integral very differently. Okay? So simplifying is generally a really good. We've seen different ways that we try to simplify these integrals. And then the last technique that we have right now, we're going to add to this list at some point when we get back from spring break. But the last technique that we have is substitution. Okay? And you remember what we're looking for here, substitution came from the chain rule. So we're looking for composition, or we're looking for the du, something to be the derivative of something else in the integral. And so when this happens, you usually let u equal that inner function. U equal the inner function. So that's what I would do here. Notice the top is kind of the derivative of the bottom, so I would, of the thing that's inside the square root, so I would let u equal 1 minus x squared, and the top is going to be, in this case, in the case of this integral, the top is basically the du. Okay? So the problems that are assigned from section 7.1 that are due after the after spring break, those problems are just applying this. So you're just going to be given several different integrals, and you have to think through what's the best step that I take in order to either, do I have a rule for it? If I don't, is there a way to simplify it? If there isn't, do I see a substitution? Do I see a composition or a natural du in there? Okay? So that's it for the lecture for this. You should have some time here. Take that time and just work on those problems. And Miss Barbo is there to answer any questions you guys might have. Hope you guys have an awesome spring break. I'll be praying for you guys, praying for your travels, just praying for some opportunity for rest, for you guys to have some great family time, for you to be rejuvenated and refreshed for when you come back to tackle. Not very long, actually. You only have, when you come back, believe it or not, you're only probably going to have about a month and a half, maybe less. And I think all of you are seniors, so that means a month and a half left, really, of high school. So that's great and scary and all of those different emotions all at once. So I know that many of you still have some decisions that you're also making. So I'm praying for you guys in the midst of those decisions for what's coming in the near future too. Have an awesome spring break. Take care, and God bless you guys.